All right, what if I asked you the molecular geometry of several molecules? Well, your first thing to do is you need to draw the Lewis structure. So let's go through several examples. I'm going to go ahead and start with water, H2O. So step one says add up all your valence electrons. All right, each hydrogen has one valence electron and oxygen has six. That leaves me with a total of 8 electrons I get to play with. Step two, put the different one in the middle. We're going to put oxygen in the middle and we're going to connect our hydrogens to single bonds. We just used up 4 electrons. 8 minus 4 is 4. Step three, fill the outside octets. Don't put any more on hydrogen. Hydrogen's a baby. It's already full with 2. It can't go on the outside. So, step 4, put the leftovers on the middle. 2, 4. We use up 4, we're done. We ask ourselves, does our center have its 8? Let's take a look. Oxygen has 2, 4, 6, 8. We're done. All right, now, as for the geometry, we have what's called an electron domain geometry, and then we have a molecular geometry. Well, let's see what those are. For the electron domains, you kind of have to do that first. Count the electron domains. We have 1, 2, 3, 4 domains. 4 domains are going to arrange themselves into a chicken foot configuration. Therefore, the geometry for all the electron domains is tetrahedral with angles of 109.5. Now, we want to know what the molecular shape or the molecular geometry is. That's not necessarily the electron geometry. We want to say, where are the atoms? How are they arranged? So, out of this, we have 2 bonds, but 2 of these are ghosts. Let's ghost out 2 of these. I'm going to ghost 1. I'm going to ghost 2. What do I see? What's left is 1, 2, 3 atoms, but those 3 atoms are not in a line. That line has been bent. So this has a bent molecular geometry. All right, let's try another one. What if I asked you for the molecular and electron domain geometries of Cl chlorine trifluoride? All right, so step 1 is we have to add them up. Chlorine has 7 valence electrons. Each fluorine has 7 valence electrons also. That leaves me with 21 and 7 more, 28 valence electrons. So I'm going to put the different one in the middle. I'm going to put chlorine in the middle and attach 1, 2, 3 fluorine atoms. I just used up 2, 4, 6 valence electrons. I have 22 left over. Fill the outsides first. 2, 4, 6, 8, 10, 12, 14, 16, 18. Take away 18, that leaves me with 4. 4 go on the center as pairs. 2, 4. All right, so the last step, does our center have 8? Yes, 2, 4, 6, 8, 10. Chlorine has more than 8. It's okay because it's third row or below. Now, we're going to go ahead and establish what the electron geometry is and what the molecular geometry is. So the electron domain geometry is, hey, where does everything go? Count your domains. We have 1, 2, 3, 4, 5 domains. 5 domains will arrange themselves as follows. 1 up, 1 down, 3 in a ring around the middle. This is a pyramid on top and a pyramid on the bottom. We call this trigonal bipyramidal. Okay, so all of the electrons go into a trigonal bipyramidal structure. Now, as far as the molecular geometry goes, we have to see what's left over after we ghost out our lone pairs. So I'm going to draw my 5 domains. One up, one down, 3 in a ring around the middle. Now, this is the only geometry that matters who we ghost out. If we look at this, we have axial positions top and bottom, or the roomy equatorial positions in the middle. You always want to ghost out your middle ones. We have 2 lone pairs. We're going to ghost out 2 of these, a ghost, a ghost. What that leaves us with is a shape that looks like a letter, and we call it T-shape. All right, hope that helps. Let's do one more example. BRF5. Step 1, add up your valence electrons. Bromine has 7. Then we have 5 fluorines, each with 7. 35 and 7 more leave me with 42 electrons. I'm going to put bromine in the middle and connect 5 fluorines. 1, 2, 3, 4, 5. 5 different Fs. We just used up 2, 4, 6, 8, 10. I'm going to take away 10. That leaves me with 32. Now we go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. Take away 30. We've got 2 left over. They need to go on my center atom. So let's establish our electron domain geometry and our molecular geometry. Electron domains. Put all the electron domains. How many? 1, 2, 3, 4, 5, 6. 6. 1 up, 1 down, 4 in a ring around the middle. That is an octahedral arrangement for our electron domain geometries. Now for the molecular, what do we see if we ghost one of these out? For this geometry, everything's at 90. It doesn't matter who we ghost out. I'm going to ghost out my top one. I have 1 lone pair, 1 ghost. That leaves me with a pyramid that has a square base. This is square pyramidal. Okay, I hope that helps. Keep practicing. Take care.